Wow. That intro video is like meditative and calming. I feel like
that's pretty cool. Yeah, really did a fun job with that.
Absolutely. So we're here. I'm sorry to all of our listeners and viewers at home. I'm au naturel today. I got booted out of my conference. I'm decentralizing the stream, as it were. But I'm here with Lagrave Nakfep, who is. Are you the editor-in-chief? Are you the editor-in-chief?
I am the editor-in-chief.
He's the editor-in-chief of the USTJ, which is the Urbit Systems Technical Journal. I always want to call it the USTJ Journal. That's wrong. Urbit Systems Technical Journal, right there. Which is the journal that's launching today. Actually, it went live 7 minutes ago.
Yeah.
So this is very, very hot off the presses.
Bleeding edge
technical journals, which I will allow Lagrave to kind of give you more of the info of what the journal aims to be, the genesis of it. So why don't you kind of walk us through, where this came from and what it aspires to be?
So, all right. So Urbit is a project that has had a lot of interesting, innovative foundations. I mean, the decisions to reduce everything to knock and then rebuild the entire computing stack back up, the capacity to overlap this or interface this in some way with the legacy computing world through different protocols, and the way that it's given some freedom and flexibility to try new things. All of these have worked together to make the project something that is generating an immense amount of novel applied computer science. There's a lot of things that people have done in Urbit that are valuable, but at the same time, Urbit as a project has functioned a little bit as an event horizon, which is that once someone gets hooked on Urbit, they tend to
disappear.
They want to work on Urbit. They don't want to go write JavaScript frameworks anymore, which has actually made it hard for us to sort of communicate the scale and ambition of certain parts of the project. And so for years, I mean, going back 10 years, people have kicked around concepts of what if we did an Urbit book? What would an Urbit textbook look like? And even back in 2020 or so, I taught the grad seminar on Urbit at University of Illinois. And one of the ideas I was thinking very actively about then is what would an Urbit textbook actually look like? What would we do if we had such a thing? But the problem that we always ran into is, well, number one, Urbit is evolving fairly quickly. There's new capabilities coming online. At some point in the circa 2018, 2019 timeframe, there was a knock decrement from 5K to 4K. Although there's not another one of those envisioned. But, the system has been evolving, sometimes slowly, sometimes rapidly, which means that if you're going to do the work, if you're going to do the work to do a book, you don't want to have to do the same amount of work or a commensurable amount of work again a year or even 2 years later, right? It's a huge amount of work to do.
Yeah.
Now, the nice thing about, and then we had, a friend of the project proposed to us the idea of riffing off of the old Bell Labs Technical Journal.
Yeah.
Bell System Technical Journal, Bell Labs Technical Journal. It had a couple different names over its lifespan. And so when Bell Labs was the one of the powerhouses of functional networking and early computer science in the United States. A lot of things were innovated and developed there. And it was really driven by practical concerns, right? They had to build and operate the monopoly telephone network in the United States.
They were the telecommunications industry.
Right. And they had to answer questions that no one had even thought about how to do, right? So when Claude Shannon published information theory for the first time, he published it in Bell Labs Technical Journal. That's where it was. So we said, well, we're doing innovative things. Let's take a page out of Bell Labs book and just start publishing,
it's interesting because, No, I mean, it's interesting though, because I unfortunately have spent some time in academia, and we think about the these journals of research now as being like, I wouldn't say, I guess they're private, a lot of them technically, right? But they're not corporate. And so there's no like Tyson Journal of Animal Husbandry, or the Monsanto Journal. I mean, right? But that's like a problem. I mean, that is a problem, because a lot of actually applied stuff happens in the private sector, as it were, right? So this is kind of us doing this, kind of a long tradition, like you're saying, of rethinking, like, where does this research happen, right? And how does it get distributed?
Right. And to some extent, it has to happen in a place where you think of what you're doing as a public good, which is possible when you actually have a true monopoly. Bell Systems was, they didn't have a reason to worry about trade secrets or IP to some extent, because they were the network. Urbit is kind of the opposite way. Open source projects in general are trying to say, well, we're the stewards of building this, but what we're building is a public good, and we want people to use and employ and build upon it. So in both cases, the incentives align to publicize what you're doing as clearly and publicly as possible.
Yeah, I mean, it's also interesting to think about, some of these things about Urbit that we've done now being able to be accessible to other projects that are, maybe not Urbit. I mean, I just think about the example of AO Computer, Arweave's new thing. I'm not sure if you saw that, but they explicitly take, inspiration from some of the stuff Urbit has done. And I think you're going to start to see that more and more, where, maybe people don't want to do the whole Urbit thing, but they think some part of what we're doing is valuable, and some of the questions that we've solved have been valuable. So maybe this will help that, right? Like get generalize some of these ideas.
Well, and I mean, that's one reason that we pluralized systems in the title, right? It's Urbit Systems Technical Journal, because we're recognizing that there's a lot of kinds of things that are Urbit or Urbit-like or Urbit interfacing or riffing off of or echoing the kinds of things that are part of. I mean, so there's actually like there's an identity question here now, right? Like, what is Urbit? There's a simple reductive sense in which Urbit is the thing that is made by Urbit Foundation and formerly Swan Corporation, right? But there's also a sense in which something that fluently speaks Knock is definitely an Urbit system, right? I mean, maybe you end up lowercasing it or something. It partakes of Urbit nature. Yeah. But
so that's exciting. So this is just the first one, right? So what's the plan? What's the like release plan in terms of logistics of the journal?
Okay, yeah. So we branded this one. This one has 7 articles. It's about 150 pages, and it's volume 1, number 1. So we're going to put out multiple issues every year. Right now, I'm aiming at a spring issue and a fall issue until I sort of have a feel for what the content pipeline is going to look like. I actually think content is not our problem. Editing, like me as bottleneck editor, is actually more of a problem. But Noah Kuman of Mars Review of Books warned me about this. So we're going to try and put out 2 a year, and we could dial it up if we need to, and there's a lot of motivation there, but definitely 2 a year. And we're just going to put these out indefinitely. Like, we're just going to keep.
I love it.
I mean, there's new things being done. One of the things that I said when we spec'd this out was that we aren't going to be. So it's a technical journal, not an academic journal. And one of the flexible advantages that gives us is that if we want to publish some older material that is still relevant, we can. Like, we don't actually have to publish things that are this year's new research. If we go back and we find, for instance, Pilfer Pandex had extensive documentation on Hoon 141 Kelvin type system. Taking some of that material, punching that up as a description of here's what static, the scope of statically typed Hoon as a language, and updating that and publishing it under his name would be a reasonable thing to do for us, because it is part of the exposition that we're trying to make of here's what the complete system has attempted. We're not averse to publishing. I don't want to call them dead ends, but like roads not taken.
Yeah. That's
right.
Really,
like there's
because then you can see kind of. I mean, I think that's kind of what happens a lot with the work product like Urbit is you just see the kind of the end result, and you don't see the things that were kind of attempted and discarded for various reasons. And for someone else's context, those constraints might not be the same, right? So it could have been discarded by Urbit, but doesn't need to be discarded by another project or another researcher. So I think it's good to have those kind of missing links, as it were, or whatever they're called.
Well, we have two articles here. The one on the future of scrying in Urbit. So scrying is reading into the bound namespace in a referentially transparent way. So this piece actually explores seriously. So this is by Ted Blackman, Paul Driver, and Matt Levan. This piece explores seriously two different alternatives for changing some of the mechanics of scrying in a way that better meets the referential transparency needs of the system without having to carry around something that kind of feels like global state.
Yeah.
Now, those two solutions they're not mutually exclusive, but it's also not clear that we will implement either or both of them, or try some third thing, or decide that it's not a problem. It's an exposition of possible futures for the way that we elaborate the system. There's another piece here, the floating point arithmetic one that I wrote, that at the end I list 6 different possible solutions to the problem that we're facing, of which Urbit at the current time explores 2.5.
Yeah.
Of those, right. So it's we're writing it down because at some point in the future, we or someone else is going to need to know what was explored, what was figured out, what was the state of the art of our knowledge.
Yeah.
And where can you go?
I think that's super important. I think it'll be really interesting reading, both for people who are into Urbit and people who are just like outside. I mean, I think part of the idea is for this to grow the surface area also for technical people that are kind of interested but don't have time to be hacking on this stuff all the time.
Now, let me see if I have a banner here for the site. I do not. So let me do ustj.urbit.org if anyone wants to take a look at the site that's live now.
It's live now, so people can go and order their journal right now, right?
Yes. And so it has a link to purchase. And then, so I guess I should talk a little bit about what we're going to do is we're going to sell hard copies, and over the next couple of months, every couple of weeks, we're going to release a new article from it online for free. So eventually all of this will be open access journal. We're going to roll it out slowly, but if you want a hard copy, your two options are to either buy one because you want a hard copy, which is fantastic. And I think that, someday when we have 10 of these, they're going to look really good on the shelf. Or we are going to distribute them at certain events or conferences. LambdaConf is next week, and anyone who's going to LambdaConf is going to be getting one of these with their swag bag. Lake Summit this summer is going to have one. Have these available. Other events that Urbit appears at in mass will also have these in person for you to acquire, should you desire.
Outstanding. So people can go to the website, or they can go to an event, or if they have, if they're averse to having more books in their house, they can just read it online, but they got to wait a little bit longer, right?
Yep.
Beautiful. Well, we have in the wings here waiting a few of the authors that are in this issue. Is that correct?
We do.
Why don't
not everyone, but some of them.
Why don't I minimize myself? You can kick me out. I don't know how this live stream stuff works, but why don't you bring up some of these authors? You can kind of dig into some of these pieces that people have worked on.
All right, let's see. Let me go ahead and call in. I'm going to call in mopfel-winrux and put Jack on deck to come in next. So, hello, Mopful. How are you?
Hello.
There we
I'm
go.
doing well. Yes.
So your piece in here.
Well, before that, congrats on the launch.
Thank you. I'm thrilled to actually have this out the door.
Yes.
Both because it means it's one fewer thing for me to think about for a few days until I start working on an issue 2, and because we've been sitting on a lot of great stuff for a while here that has. It's nice to actually get more eyes on this and share it.
Yes. I agree.
So you were the principal author of the Lick vein in Urbit, and
yes.
you wrote a piece on Urbit's IPC interfaces. Do you want to tell us a little bit about what that piece looks like? I mean, there's the the light's not going to make it happy to look at, but
no. So Urbit's unique that in the operating function that it has it doesn't necessarily have inputs it can take. And well, it doesn't have ways of interacting with the outside world other than them injecting an event into it is a better way of saying it. And these events can be anything, right? Like it could be a keyboard press, it can be a like HTTP packet, it can be an AIMS packet. Why can't it be an IPC packet? IPC is an inter-process communication. Why can't another piece of software on the system directly talk to my Urbit? And we kind of had this with Con, kind of. You could use Con to eject a raw event, but that's dangerous and not. You can blow your ship up. You can also use it to start threads and do other things, which is okay, kind of useful, but not really treating the outside world as a raw, not really speaking a not a poke language,
noun.
An input, a noun. Yeah, a noun. Right? It's all a noun meaning something else. So Lick is Urbit's noun interface. The way it's actually described, the way it's actually
so like IPC is actually almost kind of a distraction in a sense from.
It doesn't matter. Yeah, it doesn't matter. It's the interpreter can pick IPC to be the event injection. Mm-hmm. Right? It could be anything, right? IPC is just the most common one, but it could be any sort of. But it exposes this to user. It exposes this to user space also. So your user space app can purposely talk to something running on Earth, which is nice.
So your piece kind of goes through. I was gonna say your piece kind of goes through the Con KHAN vein, con.c, CONN.c, and then Lick, which is the low level IPC.
Yes.
Manager.
Yeah, it works pretty well. Yeah, we use it quite a bit with Native Planets devices. That's why we built it. We kind of needed it. But yeah, it works pretty well. We do a self-hosted LLM through it, as well as having an app on Urbit that lets you control your hardware, so you can like manage a bunch of ships running on your device. So it's a useful vein. I've done fun projects with it too, but those are the big production use cases.
Yep. Well, so yeah, his piece in here. What agreement hath Mars with Earth in exploration of Urbit's IPC interfaces? So, yeah, that'll be that. Like I said, that'll be released online. It's like the 5th article in here, so probably in a month and a half. And otherwise, you can acquire a physical copy to go ahead and read that sooner if you're interested. Mopfel, anything else you want to say before I switch us over to Jack?
No, Jack's stuff is fun too.
All right, thank you for your contribution here. I look forward to dozens of future articles authored by your hand.
Oh gosh, that's a lot. Okay.
All right. Talk to you later. All right. Hello, Jack Fox.
Hi, Neil. How are you?
Dosreg, you're on deck next. Pretty good. How are you doing?
Good, and thanks for a stellar job editing this journal. I know that you made my article readable, and you also get credit for coming up with the title, and it's a good title, I think.
Well, shucks. Yeah. So your piece is a philosophy of inductive testing, and it's Urbitish in that your examples are drawn from Urbit, and in particular from your work on URQL and Obelisk. But then you're also kind of just talking at a higher level about a philosophy of testing built on inductive reasoning. So you want to tell us a little bit about what you did and where you went with that?
Yeah, sure. Let me give you a little background of me. I've been in the trade long enough that I used to, when I ran projects, interview and hire QA analysts. I don't even know if that job really even exists anymore. Now that we're in the age of programming language that if they compile, they work, right? So yeah, I've written test plans, done the whole thing, supervised QA teams. And actually, I've got a couple slides. Is it all right for me to do a little spoiler here?
Yeah, go ahead.
Yeah, okay. Let me present here. Let's see.
Yeah, I think.
Oh.
Yep, I will. There we go.
Actually, that was the wrong screen.
Well, if it was the wrong screen, it's a safe one to be showing here. So.
Yeah, how do I back out of this? Let's see.
There you go. Try the.
Oh, there I am.
Try the other screen
Okay.
share.
Yeah, I'm going to try it again.
All right. Yeah. So I guess while you're pulling that up, I'll just talk a little bit more about what you've got here at the high level. So you walk through sort of the idea of testing frameworks and unit testing, and then you get into this intriguing way of building up the concept of what constitutes sufficient testing based on mathematical induction, and
right,
pushing things along that way. But then some of the ramifications of trying to deal with those and handling test failure as a result of that. So
right. Well, since I can't seem to be able to share these slides with you, I will just continue anyway. So the question is, like I said, in today's world where things just work, why would you even want to build a test suite? So in my case, with the project that I'm working on now, which is building a database engine, the first time that it doesn't persist data correctly or it retrieves data incorrectly, people are going to lose confidence real fast. So there are some projects where you really do need to build a test suite. But even the ones that aren't quite as critical, there's still some good reasons for doing it. One is your test suite can act as a specification, actually. And that's a useful thing to have, both to work from yourself to organize your thoughts correctly, and for others to see what your project is really doing. And with this, you can refactor with confidence, right? And if you're doing a complicated project, chances are you're going to be doing multiple refactorings of it. So yeah, there's that. And lastly, it also serves as documentation, which is, specification is a specific kind of documentation. So those are the reasons I find to be doing it.
Okay. I mean, building it around specifications and handling it and everything. Even error messages, like, are the correct errors created? Your piece is actually also drove us to introduce a new. I think this is still sitting in a pull request, but the ability to test an expected failure with a message, which is not a bit of code that anyone had built and implemented previously. So there's new testing capacities exist in Urbit because of this piece. Rather than just documenting something, it actually drove some development there.
Right. So let me speak a little bit about inductive testing. So if you're familiar with mathematical induction, it's the idea that you prove the first thing in a series. So it works on things that end up being series, and then you prove the next one after that, or some arbitrary one after that. So that brings to mind, right away, the recursive types that we have, which include things like lists, trees, sets, maps, queues. But those aren't actually the only inductive types. There's the something or nothing type, which is in Hoon that's called unit. Other programming languages call it something else. And Boolean is also an inductive type, actually, although Hoon does not support Boolean. But what all these have in common is they can all be nothing, which I find this kind of metaphysical in a way, that from nothing, all sorts of other things arise, right? So the idea is that you test the nothing case, and then you test one of the something cases. And in theory, that is all you have to test. So using inductive types and reasoning like this lets you right away zero in on exactly what you have to test, and try to avoid superfluous tests. Now, I don't recommend that you necessarily stay this this minimalistic with your testing. There are other things that are a good idea to test, and one of them that I advocate for is you should always test all your examples. There's nothing more embarrassing than a user stumbling on your project, finding some examples that you posted, and then they don't work, right? So yeah, there's that. And then so there's really two required tests in theory for an inductive type. And if you've got multiple inductive types coming into your function, or in Hoon parlance, what we call gates and doors, then two input parameters essentially squares the number of tests you have to do. 3 brings you to 3 dimensions, etc. And I call that the first Cartesian explosion of required tests. And then there's a second Cartesian explosion, whereby in some cases there's separate code paths within the function for particular values.
You cite things like complex XML or UTF-8.
Right. Yeah. Right. So that's pretty much the gist of the whole thing. It was a fun project to do, and it was fun working with you to hammer it into shape, and looking forward to seeing it published.
All right, fantastic. Thank you. So again, that's Jack Fox's A Philosophy of Inductive Testing, which will be released online, and it's the 4th article, so probably a month or 6 weeks. And if you want it earlier than that, then go to ustj.urbit.org and you can acquire a physical copy and go from there. Thank you, Jack.
Sure.
All right, Dozrag, let me pull you up here. How are you?
Good.
Pretty good. How are you? Yep. I can hear you, so we're good there. So you are the principal author of URWASM, formerly UWASM. It's had a couple names over its lifespan, and then you did a public demo of this virtual machine for WebAssembly at Assembly last year.
Right.
And now you've written it up, and the project has continued to evolve. And so your piece in here is just kind of a general exposition of the project as it stands and its near-term aims. So you want to tell us a little bit about that?
Yeah, sure. So as you already said, Urbit started as a project during the hackathon last year. I kind of decided to work on WebAssembly interpreter on Urbit somewhat by chance when I was asking hackathon organizers what projects they would like to see in the core development nomination, and they gave me a long list. And among them, there was the WebAssembly interpreter. And at the time, I wasn't really familiar with like interpreters at all. It just wasn't really my expertise, but it caught my attention because, well, as I was reading more and more about WebAssembly and trying to understand what it is and what it is used for, I saw that it could really unlock the possibility to run code from other languages on Urbit, because there are a lot of languages that can have WebAssembly as the target. You can write code in Rust, in Go. You can even run Python in WebAssembly, actually, even though you cannot really directly compile it to WebAssembly, but there is a runtime of Python written in C and compiled to WebAssembly, and you can do that. And well, as I was working on URWASM, and back then UWASM, during the hackathon, the bounty was posted, and I decided to continue working on it, and that's basically, the journey was basically continuing. And as I was finishing the first phase of the project, which is the WebAssembly interpreter proper, I was having different thoughts about the strategies on how to jet it. And I outlined a document, a gist that I circulated among the core devs, where basically I list different solutions for jetting, and I give the proposal for the solution on which I was working on right now, which is the so in the article I list different methods of jetting WebAssembly, and for certain reasons which are outlined in the article, I converge on the idea that there should be like a higher level interpreting function that takes the WebAssembly binary file with the script and some other parameters and runs the script against the WebAssembly module and produces some result. And well, basically, and this guest essentially evolved into the article in the USTJ. And this was published, like the guest was kind of circulated among the devs in February, I want to say. And at that moment, this interpreting function was like pure vaporwave. I had general idea of how it should look like. I had like a general shape in my head, but I didn't really know how to do this. And right now, I can proudly announce that this higher level interpreting function is actually complete. As of last weekend, I tested it. It works. Again, it's not Jet, it's the Jet target, but it works. It runs all the script that I gave it. It supports FFI, so foreign function interface. So for example, I could write Rust code that imports a function that feeds a string to Urbit, and Urbit computes, and Urbit compiles this as Hoon and runs it, and produces the result back pre-printed, again as a string. So it's a string-to-string conversion. Through the,
that's pretty exciting, though. That's
right,
up.
Right, through the Hoon self-interpreter, and it works. It works right now. And the coolest part of this project is that the runtime itself is 450 lines of code. It's quite small. And I envision that it's going to be quite easy to jet. And I'm going to start jetting it very soon. Of course, this runtime has dependencies. The WebAssembly runtime in Hoon is the dependency, also the Lea to WebAssembly compiler. Lea is the language for invocation of assembly. This is the language for scripting that I kind of designed for this higher level interpreting function.
And that's basically introduced in the paper here, although now,
right.
now it exists in a more concrete way than it did at the
yes,
time of composition.
right. Well, now it actually exists, because back then I was like having this thought of like Leah as the higher level interpreting, a higher level language for interpreting a WebAssembly. And right now it actually works. And so the cool part is that the compiler itself does not need to be jetted. Well, because this is not where the bottleneck or the computations are. You just run the compiler, it gives you the WebAssembly module, and now you have two WebAssembly modules. One of them is the original one that you want to run, and another one produced from Leah. And the runtime is basically like a manager of those two WebAssembly modules, kind of like Where is with Surf and King processes. There's a similar analogy, I guess. And yeah, so I'm very excited for this project.
Yeah, that's fantastic. That's really cool that Leah is ready to go now. Because yeah, I mean here, you walk through what the WASM interpreter looks like, some basic programs that run on Urbit, what the jetting options are, and now you have it. And that actually highlights one of the things that's nice about doing this as a technical journal that we put out twice a year, will be that we're not picky about time resolution, right? Like the idea is we can publish, here's what we're thinking, here's our best thoughts at the moment, and then later on we finish. We have actual instantiation of some of the things that are vaporware at one point when we're just planning and trying to figure out what's going on. So yeah, thanks for your piece. That's the final piece in the first volume, first issue of Urbit Systems Technical Journal. So you can take a look at that at ustj.urbit.org when that piece comes live, which we're going to roll out every couple of weeks for the next while there. So thank you, Dazreg.
Thank you.
Matt.
Yes, sir. How you doing?
How are you doing? So you are the architect of some of the .ket scry work that was put together here. So can you give us a little bit of background on what .ket and scry, like sort of like what that means, and then why what you did in your piece here? The piece that you're an author on, a co-author on, is The Stakes of Scrying .ket in the SEER proposal.
Yeah. So yeah, thanks for putting my name on that one. I performed role of stenographer, or as I like to call it, core dev whisperer, because this is really an old problem with scrying today. And I had the chance, well, one day I asked myself, what is a monad? And apparently there are a few experts on monads around the Urbit community, just a couple. I think one of the old marketing ploys of Urbit is it's functional programming, but you don't have to know what a monad is. So I'm hoping that that's still the case. I think it is. It certainly is. I'm being a little bit tongue-in-cheek here, but anyways, I got to sit down with Fodwhite Ragful, and he took me through monads, and then also how we could use monads to address this long-standing issue with scry, which is currently implemented with a .ket rune and compiles to Nock12, which if you pull up the Nock spec for version 4 Kelvin, you'll notice there are only 11. Well, there are 12 including 0, but there's no Nock12 in the specification. So Nock12 is this, charitably a virtual opcode, but uncharitably a fake opcode. And so that's kind of the context of the thing, but
that's actually,
yeah.
Well, so for some background on that, Curtis was working on the question of how do you sort of simulate referential transparency this way, even for years before Urbit became a project, even years before the original blog post there. So the concept of something like both directly looking into a bound immutable namespace and simulating it in a faster synchronous way have both been around actually longer than Urbit itself, even in the way that we think about them now.
Right. It reminds me of the ambition that we want fundamentally asynchronous operations to feel synchronous. So
Yep.
whether you're getting data from your own ship's local namespace or from, somewhere else across who knows how many hops in the network, it should feel the same. And so I guess we have yet to completely prove that out, but
well, the paper doesn't, the paper presents a couple of different alternatives as recommendations of like how you could do this, but
yeah,
it's not a hard commitment to do either even.
Right now, the best of my understanding of how the current scry system works is that .ket compiles to a NOC 12, and then the interpreter, the runtime, is responsible for seeing it and providing an extra piece of data called the scry context to the subject formula NOC computation. So the problem with NOC 12 and .ket is that principally it breaks NOC's referential transparency, because not only do you need subject and formula for the computation, you also need scry context. And this was implemented in this fashion as a ergonomic affordance. So
it's very ergonomic. Like
it is very.
I know. I can tell why it's there. Yes.
Yeah, it's like a maxed out GET request. So, well, if you're going to remove that scry context from your subject formula computation, how do you provide functionality for scrying? And so the seer monad, which is actually not even an official proposal yet. This is actually in draft. We've got the Urbit improvement proposals, and in the Urbit GitHub, you can see the repo called UIPs, or as I like to call them, WIPs. And so this is a draft pull request still. So this is not even, but Sarpin Laplux has codified a similar strategy for scrying based on monads, and I think he's got a branch up for that somewhere. Yeah.
So you did some of the code implementation of minimal working examples of how these would function and how potentially they could resolve some of these issues for us. So thanks for your contribution in that regard. I guess anything else you want to add about that piece, or kind of the big picture there?
Well, at least with the seer monad, I don't know whichever the other sort of competing solutions to this issue are in the paper.
It's the move-based scry interface.
Okay, right. Do you want to summarize?
No, I mean we'll just leave it. It's they're
there.
Expounded upon in there, but they're both just proposals for how you might preserve the properties of Urbit as a single-threaded solid-state event log while maintaining some amount of ergonomics on utilizing a referentially transparent namespace in a better way.
Yeah.
And then once you have it, right, like once you have seer monad and these other things, you might be able to do some performance improvements in user space as a result of that too, which is, one of the hopes for being able to build that. So.
Yeah, so it's worth a deeper look for anybody who's interested in that.
All right, fantastic. Thank you, Matt.
Thanks.
All right, we'll probably go ahead and wrap this up pretty quick. But what we're doing today is we're looking at the Urbit Systems Technical Journal. Volume 1, Number 1 is coming out It is now live on the site for ustj.urbit.org for you to take a look at. And these are, this first one is 7 articles that sort of run through some of the concepts that we've been exploring in Urbit for a while here. The first piece, actually, Ted Blackman, the CTO of Urbit Foundation, wasn't able to be here today, but his piece is The State of Urbit 8 Years After the White Paper. And it's a quite in-depth examination of what Urbit said and purported to accomplish in the initial white paper when it came out in 2016, and the actual realized state of many of those suppositions and promises in the 8 intervening years, and some parts of the system that have been re-architected, and just essentially around like how that vision has come to be realized in practice and institutionally as a result of that. Second piece is that piece on .ket and scrying and how these things might, like how do we handle the referentially transparent namespace in an ergonomic way. We have Jack Fox as a philosophy of inductive testing. We have a piece on static versus dynamic linking, which is looking at a solution to resolving the classic conflict in computer science build systems between static libraries and dynamic libraries. So are you producing a library that's compiled into the binary of the system that you're working on, or are you providing a dynamic library live on your operating system that you're connecting to, but then you run into all sorts of version issues and so forth, DLL dependencies on Windows or other kinds of library dependencies on Unix-based systems. And Urbit has grappled with the same problem internally and come to a decent solution to resolve that tension between static and dynamic libraries. So there's a piece there that goes into detail on that by Rob Nussrichfer and Wickdev Wisright. There's mopfel-winrux's piece on Urbit's IPC interfaces. There's a piece by me on deterministic floating point arithmetic that I will be presenting at LambdaConf next week. And then Dosric Topload's URWASM WebAssembly Interpreter Suite paper as well. So yeah, again, so if you're interested in a hard copy, we have those available. If you are going to an Urbit conference or a conference at which Urbit has a substantial presence, you'll be able to get your hands on one of those. So for instance, at LambdaConf next week, we're going to distribute those to attendees. So watch for that as that comes out. And we will, I'm always, as editor of this, I'm always soliciting new contributions. And if you're thinking about pieces that would be interesting to talk about within the context of solid state computing, then, pitch it to me and I'm happy to support you in writing it, editing it, and getting that published out there to take a look at. So we're going to look at putting together issue 2 over the summer and release it late summer or beginning of fall, and go from there. And I think that's it for today. So yeah, Urbit Systems Technical Journal, Spring 2024, the Journal of Solid State Computing, out now. Check out our site, and let's make computing more solid state. Thank you.